Hey, good afternoon, everyone. I wanted to do a warm-up here. I know this is from section 3.5 before we get into 4.1. This won't take much time, but it'll be neat just coming off the box plots that we did in section 3.5. I put 2 box plots so we can compare and talk about them. I'm just going to make some statements, and I was wondering if you, the class, could just tell me, true or false in my statement in reference to these 2 box plots, all right? So now if you can't justify from the information given, then go with false. You can say, hey, false, I don't have enough information to tell me that from what's provided here on the board. So here's my first statement. Ready? True or false? The median of box plot A is greater than the median of box plot B.
True.
What do y'all think? True or false? I'll repeat it too. The median of box plot A is greater than the median of box plot B. True. Very good. It's true. The median's right there, right? 70. There's the median, and the median of box plot B is the 30. Everyone know how to find that median? And you can once you have this here, you can label it. You can write stuff on your box plots like, hey, that's Q1, that's median, that's Q3, that's Q1, Q3. But the first statement we're coming out with true, right? All right. So very good. Here's my next one. 25% of the data in box plot A, 25% of the data in box plot A is less than 50. True or false? True. Good job. He says true. He says true. Very good. That is correct. Remember percentages? That's the beauty of the box plot. It tells us about percentages. So even in this drawing here, I bet a lot of you might have already done this, but it wouldn't be a bad idea to just go into this thing. Hey, well, 25% of this data is here. Then 25% is in here, and 25% is in here, and 25% is from 80 to 90. And those add up to 100%, right? And then the same thing here. You get 25%, 25%, 25% in that long whisker from 50 to 90. Cool? Hey, true or false, there's no outliers.
True.
True, Ellen, you don't see any stars anywhere, right? There's little asterisks. There's none drawn on the board. So there are no outliers. Very good. Here's my next one. The range of box plot A is equal to the range of box plot B.
True.
Now the range, that has a definition. It's max minus min. Everyone's saying true. So the max is 90. The min was 10. 90 minus 10 is 80. In this group, 90 minus 10 is 80. The ranges are equal. True? All right. I try this one. The inner quartile range of box plot A is equal to the inner quartile range of box plot B. True or false?
True.
Oh, you all are quick. They're saying true. Let's look at that. So if you're like, how'd they get that? The inner quartile range is the 80 minus 50, which is 30. And over here, the inner quartile range is the 50 minus 20, which is also equal to 30. So far, everything's been true, right? Excellent. I got another one. I want to go back to the percentages. 75% of the data in box plot B is less than 50.
Sure. 75%. Can you repeat that?
Yeah, I'll repeat that. 75% of the data in box plot B, 75% is less than 50. True. Yeah, look, 25%, 25%. So 75%, if these were scores on a test, let's say, then yes. 75% of the students in class B scored a 50 or less. Wow. Yeah, that's what we're saying. That's what we can see in a box plot. So all these statements, I'll do percentages again. Roughly, let's see. Yeah. Roughly 75% of the, if these are students in group B scored less than roughly 75% of the students in group A.
True.
Yeah, can you see that? Look, 75% of the students in group B scored less than 75% of the students in group A. That'd be a true statement. So everything I've said so far is true, right? All right, now, you get out your highlighter. Ready? Here we go. True or false? Group A and Group B have the same amount of data.
Same amount. It cannot be determined.
Yeah, I'm gonna say this again. Group A, because we know this represents data, right? It's a distribution of the data, it's a nice image, tells us about, and I'm making a statement, true or false. Group A and Group B have the same amount of data. And when I'm talking about data, I'm talking about like, think of that word sample size, right? They both have the same sample size in both of these. And we're sitting there going, no, there's not enough information for that.
Yeah.
We're gonna have to say false, because we can't justify it, all right? I mean, that's what's hidden in the box plot. I want you to highlight that. You go, we're gonna have to say, cannot justify that. This could be representing 1,000 students, or this might only be representing 30 students, right? Oh, Gary, go ahead.
I just thought that one class was smarter than others.
That's a good observation. He's like, man, which class did a lot better? But these are scores. Which one, Gary? Did a lot better. Yeah, he's like, Group A. Did a lot better in Group A. But anyway, in this case, what's the one thing of all those statements I made were like, hey, we can't justify that. This idea I say, hey, I'm looking at these because they look similar in terms of box plots, in terms of the ranges were equal. And then you go, well, then they're representing the same amount of data. We're like, we don't have enough information for that. Right? The amount of data, the number of data in here, the sample size. This might be, it's not written anywhere, but this might be sample size 987 students. And this might be a sample size of 62 students, right? And this is what we get. So that's the one thing we don't see in the box plot. You know, it wouldn't be a bad idea if you ever produce one of these off to the side to show your sample size, right? N equals 52 students or something like that. So does everyone go with that? That's the one thing I want to point out. You go, okay, we don't